Hey guys, welcome to Coding with NJ. In this tutorial, we are going to implement the sliding puzzle game with just vanilla JavaScript and Canvas API. That means we are not going to use any kind of frameworks or libraries. Isn't it cool to implement something from scratch without the help of any kind of gadgets? Besides being cool, it makes us a better programmer and ready to take on any kind of frameworks much smoothly and quickly. Before we jump into coding, let me entice you even more by giving you a peek into what coding skills we are going to learn today. Well, to begin with, we are going to learn nitty-gritty details of the game logic itself. We will learn how to chop up a single image into multiple pieces through JavaScript. We will also learn at least 2 different formats in which we can place an image on the canvas and extract it. Did you know that once an image or any number of images are placed on the canvas, to the canvas itself, those images themselves are just a collection of pixels, and there is no concept of an image as we know it. Now clearly this is a challenge for our sliding puzzle game because it consists of individual pieces of images which we can move around. So if there is no concept of image, then no concept of multiple images, and we can't move them around. Well, if you follow along, you will also know how to get around this problem by the end of this tutorial. We will also learn the logic to associate a click event with each puzzle piece to make it move, even though for the canvas there doesn't exist any image. Therefore, we cannot associate a click event listener with the image pieces. So this is another interesting bit that we are going to learn. I almost forgot, we are also going to see a practical application of Singleton Design pattern as well. Well, there are many interesting things that we are going to learn today. So let's just get to it. Okay, so in the project folder, as you can see, there are 2 files already there. One is the image that we will be using, and the second is index.html. Now, if you notice in the index.html, we only have just 2 elements in the body of HTML. One is canvas element with the ID canvas as well, and second is the image that we'll be using. I put this image over here so that you can see the actual size of that image. So let me show you in the browser. So this is the image that is being displayed with its original width and height. So we have to somehow squeeze it into this canvas size. And currently, since there is nothing in the canvas, so we can see an empty space over here and nothing else. Now we are finally ready to do our coding. Since all the logic is going to go in the JavaScript file, so let's create a JavaScript file. And let's include this file in the HTML. Let me just set the background color of the body. That's it, no more styling. Now let's go and start working on the JavaScript file. We are going to create a class named board. So this board class is going to contain all the configurations such as the width and height of the canvas and the height and width of each tile piece of that canvas, the total number of tiles we want to break an image into. For the demo, I have used 2x2 puzzle because with 4 puzzle pieces the game ends quickly, and I could show you the different stages of the game from beginning to end. But we can make this puzzle with as many tiles as we like by just changing one number in this class. So these kind of configuration information I am going to place in this class. This way, if I need to change any of these settings, I just have to make the change at just one place, that is this class, and it's going to take effect throughout the project. Okay, so let's start with constructor. Now to this constructor, we need to pass 3 parameters: the original width of the image that we are using, the original height of the image that we are going to use for the puzzle, and the total number of rows and columns we want to break this image into. We want to break this image into and create that many number of tiles. So I'm going to call it image and width. So this is the actual natural width of the image, and image natural height, and row columns. So this is going to be just one value. If it's 2, then we are going to create a 2x2 column. That means 2 rows and 2 columns. If the value over here is 3, then the puzzle that is going to be created is going to be 3x3. That is 3 rows and 3 columns, and so on. If you notice, I am saying natural width and natural height. By natural width and natural height is the actual size and width of the image. If through CSS or in the index.html itself, we change the width and height of the image, then the width and height attributes of the image are going to give us different number compared to natural width and height. So the natural width and height is always going to refer to the original image's actual width and height. And just width and height attributes are going to give us current width and height according to the values of width and height that we have set in the either in the index.html or through CSS styling. So we are going for natural width and natural height. This way we are always certain that it is going to take into consideration the original image size. Within this constructor, the first logic that we need to actually define is the logic that converts this board class into a singleton class. But for the time being, I'm holding this off because currently we don't have enough information that justifies why we are converting this board class into a singleton class. So I'm skipping this part and continue with the rest of the configurations. Once we have done enough coding that it makes more sense to convert this class into a singleton class, we will come back to this constructor and convert this class into a singleton class. So skipping this part, let's just continue with the rest of the configurations. And the first thing that we want to set is the width and height of the canvas that we want to have for our puzzle. So this dot width is going to be, I'm fixing it to be 600 wide. You can change these settings if you like, if you want to make it a bigger puzzle or a smaller puzzle. It's going to create 600 by 600 canvas. So the canvas is going to get width and height from these properties. Then we have to decide how many puzzle pieces we want to break our actual image into. And that decision is directly linked with our number of rows and columns in the puzzle piece. If we want our puzzle piece to be 2 by 2, then we have to break our image into 4 pieces as well. If we want our puzzle to be 3 by 3, then we have to break the image into 9 pieces as well. And since the number is going to come from this one, so this means this dot width of image piece. So this IP represents image piece, not the tile on our canvas, rather the width of each piece of the image. And we have to get it by dividing the original width of the image with the number of rows and columns. Now since this can return us a floating value, so we have to pass this value into math.floor. We have to do similar for the height. Since number of rows and columns are going to be the same, 2 by 2, 3 by 3, so we are dividing it by the same number. So if it's a 2 by 2, then the natural width divided by 2 gives us 2 columns. And natural height dividing it by number of columns gives us total number of rows. Now this width and height is actually the width and height of each piece of the original image, not the piece on our puzzle. So let me put some comments. So this width and height is puzzle width and height, and this one is Now let's define the width and height for each tile piece on our puzzle. So we have to get the width and height of each tile piece by dividing the total width of the puzzle with the number of rows and columns that we want to have. So that means this dot width divided by this dot row columns, and again we have to pass it to math.floor to get an integer value. So that reminds me, we have to set these values locally as well, because we will be accessing this setting from different functions throughout the project. So this needs to be locally defined as well in the board as its instance variable. And let's put this with this. So now this row column refers to the instance variable of the board class. Let's copy and let's define the height. Okay, so these are all the settings that we will be referring to from different functions throughout our projects. So that's why it's a good idea to encapsulate them into a single class. We don't need to define any methods for this board class because basically it's going to act as a configuration settings, and once those settings are set at the time of creation of this board object, we don't need to change them. They need to remain same throughout the project. Let's move on and define some global variables. we are going to go with the global variables because this way we don't have to pass on different variables from one function to another. So to keep things simple, I'm going to go with global variables. So the first global variable that we are creating is canvas, and this is going to actually refer to our canvas element in our index.html file. The second variable is going to be context, which we are going to get by calling a method on canvas called getContext, and we are passing it value 2d with lowercase d. So we need to define this context on the canvas because we can put not only two-dimensional entities on the canvas, we can actually go for three-dimensional entities as well. So this method getContext actually sets our canvas for two-dimensional manipulation, and you can think of this canvas as a plain object, and the context you can think of a top layer on canvas which actually makes our canvas ready for two-dimensional manipulation. So that means most of the manipulation that we are going to do canvas is going to be done through this context element. There are going to be one or two times when we will be directly accessing this canvas, but most of the time we are actually going to use this context element. We also need another variable. Let's give it a name board. Currently this is empty variable. Later on we will create an object of type board and assign it to this board object. So our class board begins with capital B and the variable or the object name begins with small b. But currently this variable hasn't been assigned anything. The reason I'm not creating an object of type board yet and assigning it to this variable board with lowercase b is that the constructor of this board class requires the image. We need to know the natural width and height of the image that we are going to break into different pieces. And so far there is no sign of that image yet. So until we bring that image into this project, we have to hold back from creating an object of type board. Now we need to define an array which is going to hold individual tile images. So currently I am keeping it empty. Now since these tile images, as the name suggests, are the tiles on the canvas, so that means these are just collection of pixels. Therefore, we cannot distinguish between different tile pieces by associating any kind of ID with them. But we must have some kind of way that distinguish between those images on the canvas so that we can decide when the game has ended. So therefore we are going to create another array which is going to store tile indexes. So how is this going to work? Let me take you to the demo project. So this is whole picture. Now suppose if we want to break this image into 2 by 2 puzzle, that means in total 4 pieces. So 2 rows and 2 columns. So this piece, the first piece, the top left piece is actually in row 0 and column 0. The bottom left piece is in row 0 and column 1. Likewise, the top right piece is in row 0, column 1, and the bottom right piece is in row 1, column 1. So what we are going to do is that we are going to take this first piece, top left piece, and put it at index 0 in our tile images array. But now we need to associate some kind of identification with this piece. So what we are going to do is that since we know that this piece, once the puzzle is solved, must be positioned at row 0 and column 0, so therefore we are going to get a unique ID using some formula from row number and column number. And we are going to store that ID at index 0 in our second array. In fact, let's call this second array, instead of column indexes, let's call it IDs. Because the arrays themselves have indexes, so that index and this ID, if we name it index as well, so it's going to confuse us. So therefore the better name is tile IDs. So now from row number and column number, we have generated a unique ID. The first image, the top left image, is placed in index 0 in tile images array, and the unique ID for that image that we generated from rows and columns is going to be stored at index 0 in the second array, that is tile IDs. Likewise, the same procedure is going to be applied for the bottom left image, top right image, and bottom right image. And their respective unique IDs are going to be stored in the second array with exactly same indexes. So if the first image is present at index 1 in our tile images array, then its unique ID is stored in second array at index 0. if this second image, the bottom right image, if this is present at index, let's say 3 in tile images, then in our tile IDs array at index 3, we have the ID associated with this array. And since we have generated those IDs from rows and columns, that means we can reverse the process, and from those IDs we can actually figure out the original row and column where this tile piece is supposed to go in. So this way we will eventually be able to figure out when we have actually solved the puzzle. Now, since these two arrays currently consist the image in their original setting, that is correct piece at correct index, we need to shuffle the tile so that we see randomized puzzle pieces on our screen rather than a solved puzzle. Therefore, we need to have another array in our project. So let's call it shuffled IDs. So this shuffled IDs array is going to get the values from tiles IDs after shuffling it. So the tile IDs contains the IDs at correct positions, that means correct indexes. In the shuffled IDs, we are going to randomly places the IDs position from one index to another, such that it gives us a random collection of pieces on the canvas. Now let's create an object of type image. This image object is actually going to refer to the image that we want to use for the puzzle. So now this image is an image object. So it's not img HTML element, rather it's an object of type image, IMAGE. To this object source, we are assigning it the object that we want to use for our puzzle, which is image.jpg. Image.jpg. Now, once we assign any value to the source attribute of our image object, that image, if it exists, it starts getting loaded. And when the image starts getting loaded, we want to initiate the puzzle game as well. Therefore, we are going to create onload event listener for this image object. And since the instance we assign any value to the source attribute, the image already starts getting loaded. Therefore, if we want to associate any event listener for this image, that event listener must be defined before the execution of this statement. So let's go one line up, and here we have to define the onload event listener for this image. And for that event listener, we will actually create an object of type board and initiate the game process. So image.onload equals a function which is called cut image into pieces. And remember, this line must come before this line where we are assigning value to the source attribute of the same image object. Now let's define this function. Cut image into pieces. Now we are all set to create an object of type board and assign it to this board variable. Because now the image that we want to break into pieces, that image already exists. So now we can get the natural width of this image and assign it to this board constructor. So we'll say this dot natural width. We can go for width. We can go for just width and height as well, because we haven't changed the natural width and height of the image. So width and natural width both are going to give us same values. Likewise, height and natural height both are going to give us same values, because we haven't changed the width and height of this image. And the last parameter to this board constructor is going to be the number of pieces we want this image to be divided into. So since we want to make it 2 by 2, because this is easier to understand and solve, so I'm passing 2. But if you want to have a 3 by 3 puzzle, you simply replace 2 by 3. For 4 by 4 puzzle, simply replace it by 4. So let's go with 2. I have forgot to put function keyword over here, that's why it was complaining. Okay, now we are ready to understand that this board object only needs to be created once the image object has been defined and its source attribute has been set as well. And at the time of loading, this function needs to be executed, which is creating an object of type board, because this board constructor depends on the width and height properties of this image. So unless this image comes into picture, we cannot create an object of type board. Next, since this board object only consists of bunch of settings which are going to remain the same throughout the life cycle of our puzzle, therefore we must not be able to create more than one instance of this board. Now to make certain there exists at most one instance of the board, we have to go back to the constructor of the board, and before defining any of these attributes, let's add some logic which converts this board into a singleton class. For that we are going to say if board._instance. That means if there exists an instance of board already, in that case throw an error, and you can write any message of your choosing. There can be only one board per puzzle. However, if this _instance is null, that means currently no instance of board exists. In that case, assign the current object, which is called the constructor, the board constructor, which is being referred with the keyword this. So assign that object as the board instance. So this way, if another instance is being created, this will return true. That means an instance already exists, so it will throw an error and the rest of the logic will not be executed. However, if that is not the case, that means this _instance attribute is empty or null. So in that case, assign this, that means the current object which is being created, to this board instance. So this ensures there can only be one object of type board in our project. Now let's go back to our function, cut image into pieces. Now we can define the width for the canvas to be equal to board.width. So whatever width we have defined in the board, assign that width as the width of the canvas. Likewise, canvas.height equals board.height. Now we are ready to define the logic which is going to cut this image into multiple pieces. For that we need to create another temporary canvas object. So let's give it a name, temp canvas. And since we are creating, not actually referring to the one which is present on our index.html page, so document.createElement and its canvas. Set its width and height, and the width of this temporary canvas is going to be the width that we are going to give to each tile on our puzzle. So board.tile width. Likewise, the height of temporary canvas is going to come from board.tile height. So this is going to be board.tile width, not board.width IP. So width IP represents the width of each piece of the original image. Tile width represents the width of each piece on the canvas. So we have to assign tile width to canvas width and tile height to temporary canvas height. And now we have to set this temporary canvas for two-dimensional manipulation. So let's create another temporary context. Temporary canvas.getContext, and it's going to be two-dimensional context. Now let's create a for loop. So let row equals 0, row less than board.row columns, because this row column attribute contains the number of rows and columns we want to have on our puzzle game. So if the row column represents 2, this is going to represent it. Okay. And row plus plus. Now within the for loop we need to have another loop which is going to represent the column. Again, board dot less than board dot row columns. Now during each iteration we are going to get a chunk from the original image and put it on our temporary canvas. So to draw something on the canvas we have to use temporary context, and the method that we have to use is called drawImage. Now this drawImage method is a polymorphic method. That means we have 3 different versions of this drawImage which contains different number of parameters. So we are going to go for the one which contains all the parameters. So the first parameter to this draw image is going to be the image that we want to draw on the canvas. So the image is this because we are inside the cut image into pieces function, which is actually an event listener for the onload event on this image, img image. So this image contains the image. So therefore we can refer to this image with the keyword this. So we are saying take this image. Now we have to decide which part of the image that we want to extract and display on the canvas. So we are going to say row times board dot width of each image piece. So this is going to give us starting coordinate x-axis from where the image will be started to get extracted or copied. We have to provide the y-axis for this position, which is going to come from column times board dot height of each piece of image. So these two represent x and y coordinates from where we want to start copying the image. In the next two parameters, we have to tell from this starting position how many more pixels in the x-axis direction and how many pixels in the y-axis direction. So we want one whole piece from the image. Therefore, we are going to say board dot width image piece and board dot height image piece. So first time row is going to be 0 and the column is also going to be 0. So these x and y coordinates are going to be 0. So starting from x coordinate 0 and y coordinate 0 of the image, take a chunk of that image as wide as the value defined in width IP attribute and as well as much height as defined in this attribute. Now that piece has been taken from the original image. Now we have to place it on the canvas. And since the size of canvas is equal to the size of one tile piece, so each image is going to be placed on index 0, 0 on that canvas, the temporary canvas. And then for the next two parameters, we have to define that out of the whole width of the canvas, within how much width you want to place this image and within how much height you want to place this image. So we want to cover the entire canvas. Therefore, we are going to go for temp canvas dot width and temp canvas dot height. So basically, the first 5 attributes are giving us information that from the original place, where shall we start extracting the image and how wide and how high this image should be extracted. Then for the next 4 parameters, you are specifying where shall this image be placed on the canvas and how much width and height the same image should occupy on canvas. So this way the canvas can resize the image as well. Now since we are covering the whole canvas for each image that we are extracting from the original image, if we want, we can skip these parts as well. But since we are learning to code and probably it's very first time for the canvas manipulation, so it's always a good idea to include all the attributes so that we get the muscle memory. Now since we have put this image in the temporary canvas and each iteration of the for loop is going to override this canvas, therefore we must store whatever is on the canvas currently into some permanent data structure. And for that we are going to use tile images array that we have created, and we are going to push whatever is available on the canvas. Now whatever is available on the canvas is just a bunch of pixels. We cannot push pixels into an array, therefore we have to convert those pixels into DataURL object. So for that we are going to use temp canvas dot to DataURL. This method is going to convert whatever is currently present on the canvas, that is the pixels which are present on the canvas, it's going to convert it into an object of type DataURL and pushes it into this tile images. So basically it's going to convert those pixels which are present on the canvas into this format. The starting part is keyword data followed by colon, then the image /png. Now this is the default format which is inserted. If you like, you can change this to JPEG or anything, but then you have to provide those details yourself. But if you don't, which we are not, it's going to be image /png followed by semicolon, and then it's going to convert those pixels into base64 encoding. So therefore keyword base64 comma and then the actual encoding of those pixels into base64 format. So this type of information is actually being stored in our array named tile images. Now, since the data URLs are being pushed, we need to find the unique ID for each of those images and store it in our second array. So let's ID equals row plus column times board.row column. So current row number plus current column number multiplied by total number of rows or columns. So this will give us unique ID, which now we are going to push into our second array, which we have named tile IDs. Now this for loop has chopped up the image into individual pieces, put each piece onto the canvas, convert that image from the canvas into data URL and push that data URL to tile images array, and define the unique ID from the rows and columns using this formula and push that ID into tile IDs array. Once we are outside this for loop, by now our tile images contains data URLs for each piece we have divided our original image into, and tile IDs contains their unique IDs. But so far we haven't drawn anything on our actual canvas, which is going to represent our puzzle game. So outside this for loop, we are going to call a function called shuffle. Let's name it shuffle IDs, fine. So this is going to take this tile IDs array, shuffles the data and store those values into our third array, which is called shuffle IDs. Because if we try to draw the pieces from this array onto our canvas, since this array contains the puzzle pieces in the sequential order, so our puzzle will already be solved. So we want to first of all shuffle the IDs, and according to those shuffled IDs, we are going to place the tile pieces on our canvas. So this function is for shuffling the tile pieces, and then finally we'll be ready to draw all the tiles. Now we are done with our cut image into pieces function, but this function has given us two more functions to define. First one is shuffled ID. Let me change the name from shuffled to shuffle because we have an array with the name shuffled IDs. Okay, now the first thing that we need to do over here is copy the contents of tile IDs into shuffled IDs array. So shuffled IDs equals, we are going to use a spread operator. So what this spread operator is doing is that it's going to copy each element of the tile IDs to the shuffled IDs array. Now we are ready to play around with shuffled IDs because the actual IDs in their correct position are preserved in this tile IDs array. So the way to shuffle the contents of this shuffled ID array is that I'm going to call sort method on this array. And this sort method can take an arrow function as its argument. So I'm going to provide an arrow function which is something like this, math.random minus 0.5. I have basically borrowed this way of shuffling an array from a website. Let me show you. It's this website, flaviocorps.com, and basically the way this shuffling works is that math.random generates a number between 0 to 0.9. A random number is generated greater than or equal to 0 and less than 1. So whatever number is generated, 0.5 is subtracted from that. This in turn results into either a positive number or a negative number. For example, if math.random generates a number, let's say 0.6, then subtracting 0.5 from it will return us 0.1, a positive number. However, if it generates 0, then 0 minus 0.5 returns us minus 0.5. So it's a negative number. If the return number is negative, then the two elements that are currently being sorted, they will shift their positions. However, if the result of this operation returns us a positive value, then the two numbers which are currently being compared, they will remain on their respective positions. So if you like, you can read more about this at this website. Okay, now let's get back to our own project. Now at this stage, the elements in the shuffled IDs array are actually shuffled. So we can basically end the shuffling logic over here. But when the shuffled IDs array's length, which represents the number of tiles on our puzzle board, if that is a small size, that is when the puzzle consists of just 4 elements, it's a 2 by 2 puzzle. In that case, there is highly likely chance that even after shuffling, because there are very few elements to shuffle, the IDs could be actually at the same position. So it all depends on this math.random what value is generated from there. So for each of the 4 elements in the shuffled ID, all the values are generated greater than 0.5, greater than or equal to 0.5, then the total result of this computation is actually going to be a positive number. So in that case, the elements will remain on their original positions. So if that is the case, we have to make sure that we shuffle one more time, or as many times until we get the actual shuffled items. So therefore, after shuffling the elements in the array, we have to make sure that this shuffled IDs does not actually mirror the elements of tile IDs array. So for that, we are going to use for loop. So within the body of this for loop, we are going to use if shuffled IDs at index I is not equal to tile IDs at index I. So if that is the case, that means there is at least one element which is not at its original place. So in that case, we can be certain that our shuffled IDs array actually contains contents in the shuffled form. So in that case, we have to randomly pick one of the indexes and set its contents to -1. So this -1 will represent which block is going to remain empty on our puzzle. So let blank equals, we are calling math.random. Now we know it generates a value between 0 to 0.9. Therefore, we are going to multiply it with the total number of the tiles on the screen, which we can get from board.row columns, multiplying again by board.row columns. So the first board.row column represents rows and second represents columns. Since in our case, it's always going to be the 2 by 2, 3 by 3, 4 by 4. That means the same number of rows and columns. So we are multiplying board.row columns to itself. This will give us the total number of tiles, which is going to be 4. But since array indexes start from 0, therefore we have to subtract -1. So this returns us a number which is 1 less than the total length of the array, which could be 4, 9, 16, 25, depending on how many rows and columns we have chosen. So anyway, the number that is returned, that is multiplied by whatever is generated by math.random. So if math.random has returned us a value, let's say 0.9, then multiplying it by 3 will return us a value which is 2.7, again which is a float value. So what we are going to do is that we are going to place all of this inside math.round. So this way, whatever float value is returned, that is going to be rounded off and returned in this blank variable. Next, we are going to say at the shuffled IDs array at index blank, set its contents to -1. Later on, this value -1 will indicate that tile needs to remain empty. And since within this if block, we have already made sure that the shuffled IDs array actually contains elements in shuffled form, and we have set one of its contents to -1. So we are done here. And now we can terminate this for loop and exit the function. Return. But if we have completed this for loop and we have reached here, that means all the elements in shuffled IDs array match exactly tile IDs array. So that means there is no shuffling. That means we need to go through one round of shuffling. So let's call the shuffle IDs function again. However, we will not get to this part if at least one element in the shuffled IDs array is different from the tile IDs arrays because of this return statement. So this part will only execute if even after first round of shuffling the elements are still the same. This makes our shuffling function even more robust. Now we are ready to work on the draw all tiles function. But before we start working on this draw all tiles function, let me give some border to the canvas so that we can visualize the canvas. So I'm going back to cut image into pieces, and after assigning the width and height to our canvas, the original one, not the temporary one, let's give it a border. So canvas.style.border equals, let's give it red, 2 pixel, and solid. What happened? So it's supposed to be style. Now let's define the fill color for our canvas, the color inside the canvas. So to apply, let me show you first how it currently looks. Okay, so this is how it looks. It says shuffled IDs is not a function at line 50. Okay. So shuffled IDs is array name. In fact, it's confusing, so let's change it to just shuffle. Now shuffled IDs is an array, and shuffle is a function which is going to shuffle the contents of the tile IDs and give it to shuffled IDs array. We also need to remove this image. I left it in the index.html so that I can give you an idea of what does natural width and height means. Since we will be loading this image through JavaScript and into the canvas, so basically we don't need this one. Okay, that's better. Now let's actually draw the images. But if you notice, our canvas is transparent. That means whatever is underneath this canvas, we can see it. And that is because we haven't filled any color in the canvas. So we are going to give it gray color after assigning border. So to give it a color, we have to use context.fillStyle and give it value gray. So this is only setting the color to be spread in the canvas to be gray, but it doesn't actually paint the canvas. To make this action happen, we have to call another function after setting the fill style, which is fillRect. Now this fillRect takes 4 parameters: the starting coordinates from which we want to start filling our canvas, and the width and height that we want to be filled with this color. So we want to fill the whole canvas with gray color, 0, 0, that is starting position or starting coordinates, and then we want the whole canvas, which is board, let's make it canvas start width and canvas start height. So this is how it looks. Now let's go and work on the draw all tiles function. Now to draw all the tiles on the canvas, we are going to use shuffled IDs array because we want all the tiles to be drawn in unorganized fashion. So let's use for loop. Let index 0 index less than shuffled IDs dot length So the first thing that we need to do is that we have to check if the contents at this index is equal to -1. So if that is the case, then skip this iteration of the for loop and move on to the next iteration, because -1 means we are going to keep that tile empty or blank. So if shuffle IDs at index equals -1, in that case simply continue, means skip this iteration. However, if that is not the case, then the next statement will be executed. So here we are going to call a function which we have not defined yet, get row column from index, and pass the index. So this function will return us an object which is going to consist of row number and column number for the index that we have passed. Let's store it in a variable. Let's give it name quads because it's going to represent the coordinates. Now let's create x equal to quad.x because the object that has been returned consists of two attributes, x and y. X represents the row and y represents the column. The reason I'm creating this x and y and assigning this quad.x value to it and quad.y value to y, this way instead of writing this whole thing, I can just write x, and writing this whole thing, we can just write y. So it shortens the typing. Now we have got the x and y, that means the row number and column number. So x represents the row, where the tile is going to be inserted in the canvas. Now we have to get the image that we want to put into that tile or that portion of the canvas. So what we are going to do is that we are going to get the contents of this shuffled IDs array at this index and pass it to tile's image. So whatever number or ID is present at this index in the shuffled ID, and remember now the IDs are shuffled in this array, get that ID or get that value and pass it as an index to tile images. So now whatever number is passed to tile images, from that index return its contents, which are image URLs. So we are going to store that into a variable. We are going to name it image URL. Now this tile images array has returned us a data URL which we have stored in image URL variable, but we cannot directly place image URLs on canvas. Rather, we have to create an image object and to its source assign this data URL. So when the source attribute of this image object gets assigned any value, which is an image in any form, then it starts loading into the memory. So when this happens, we want the same image to be drawn on the canvas. So that means we have to define onload event listener for this image as well. And since the onload event listener must be defined before the source, so it's a function. And within the onload event listener for this image object, we are going to define the logic to place this image which has been loaded into the memory on the canvas as well. So context.draw image, and which image we want to draw? This image which has just been loaded into the memory. Next we have to specify which part of this image we want to be copied onto the canvas. So because we want the whole image which has been loaded, because it's already contains just a portion. So starting from the 0, 0 coordinates up to whatever is the width of this image. So this dot width and whatever is the height of this image, which simply means take whole image and now place it on the canvas which represents our puzzle board. So now exactly where do we want to place this? So we are going to place this coordinates that have been returned according to the index number. So now if the coordinates are 0 and 0, so we can use x and y. But what if the coordinates are, let's say, row 0 and column 1? So if the coordinates are row 0 and column 1, so that means we have to place an image at the top right section of the puzzle. So just giving x and y will not place the image in this location. Rather, it will be slightly over here at the top left corner. So we have to move to the second tile. And we know the width and height of each tile. We simply have to multiply the width with the row and the height with the column. So therefore, x times board.tile width, y times board.tile width, tile height. Now this will give us the starting coordinates, but now we have to define the actual width and height on the board which this image needs to occupy. So we want this to only occupy a space which is occupied by one tile. So therefore, board.tile width and last board.tile height. That's it. You must remember that we have to draw this image on the canvas in the onload event listener for this image. If we do this outside this onload function, then image might never be drawn on the canvas. Okay, so that's the end of draw all tiles. Now we have to define this function, get row columns from index. Let's make it shorter. This is going to be a very small function. So the row is going to be index divided by total number of rows, and since rows and columns are same, so board.row columns. Now this can return us a floating point value, so we must use math.floor. We shouldn't use the round function because the rounding might give us a row which does not exist in our puzzle. For example, if the value that has been returned is 1.8, so it will be rounded off to nearest integer, which will be 2. And we don't have any row number 2 if we are using 2 by 2 puzzle piece. So rather than using math.round function, we have to use math.floor because it will give us the lowest integer from that value. Now for the column, again math.floor. This should be column, because we are going to get the row number by mod operator, I mod board.row columns. Now we have to return an object, x and y, assign column to it. So an object is going to be returned with attributes x and y. The value of x represents row and value of y represents column. That's it. By now we should be able to see randomized puzzle images on our canvas. Nothing. Column is not defined at index 89. Okay. Brilliant. Now we can see randomized image pieces on the puzzle. If we click on them, nothing happens. So now we have to work on that aspect of the puzzle, such that when we click on these images, and if it has a neighboring empty tile, the clicked tile should move in the empty tile, and now this tile becomes empty. And how are we going to do that? Well, even though we can see 3 different images on the canvas and 1 empty part, but for the canvas, these are all collection of pixels. So canvas doesn't know that these are 4 different images, or 3 images and 1 blank tile. And since for canvas there is no image, so we cannot assign any click event listener for each of these tiles. Therefore, we have to define a click event listener for the canvas itself. Then wherever the canvas is clicked, we have to get the mouse coordinates, and from there we have to figure out the exact row and column and the rest of the logic. So first thing first, let's go and attach a click event listener with the canvas.